This is Scott from KIG. It's Tuesday, December 10th, 2013. And this is one of two, year 2009, Edwards Engineering. That's our other one. Edwards Engineering 7-ton air-cooled chillers. We're going to do a runoff demo today. We've been testing and tweaking a lot of stuff here on the unit over the last few days, including the variable frequency drive right here. But we're going to go ahead and start the unit up right now. And it's already chilling right away. We have the temperature, I guess, gauge here. The set point is achieved here. I'm going to color this red light, it's so bright. By this Johnson Controls manual temperature gauge, and we have it down just to about 20 degrees Fahrenheit. We have a 30% glycol mixture running through a loop in the unit right now. We heated it up with ambient and this coil system that we have right here. And we got a little space heater on it. We just heat it up to about 70 degrees or so, and that actually gives a little bit of a load, so we've been cycling this on and off all day. This readout here gives us a bunch of things, most of which is helpful for a HVAC technician to monitor some of the things like liquid line, temperature, compressor suction, condenser temperature. But the two big ones here are coolant supply and coolant return. So the coolant supply right now is already chilled down to about 65 F and dropping fairly rapidly. Right here is where we have the pressure switches, the high and low pressure switches for the refrigerant. And again, this is our VFD drive for the fans. This is an outdoor rated unit. It's kind of a slick unit. It's got two fans, again controlled by the variable frequency drive. It has, in addition to a Runfos process pump here, it also has a little smaller bypass circulation pump, which constantly ensures the right amount of flow over the heat exchanger, which is inside this insulated tank right here. This gives you the level of the fluid in the tank. This is the pressure relief. And this is the wiring that goes into an internal flow sensor. Again, we just set up a loop right here, which comes to this coil that we have to give us some type of load. See, we're down to about 59 degrees Fahrenheit right now. As mentioned to the customers buying this particular unit, and it's intended for a brewery application, we did find a cap inside that was loose, and it leaked out a little bit of the refrigerant. So another nice thing is this uses R410A refrigerant. It does run at higher pressures as compared to R22. Also, both sides of the unit, in addition to having this nice coil guard, the coils themselves that you can see in there have what appear to be an E-coat. They call it coating for additional protection outside. Inside here, this is just your drain if and when you need it. That's our sight glass here. In this case here, it should be dark. You don't want it pink to show moisture. Everything looks good there. It's our dryer. It's our TXV valve in there. Compressor overall is pretty dang quiet for something of this size. Again, the units are nicely engineered. You have a hard, I guess a hard panel or hard printout of the schematic and the piping schematic. Here's the piping schematic on this door, and here's the electrical schematic on this door here. And we do have the we're able to run it without the cover just for this test to show you everything. That's the other cover right there. And of course, on this side we have the cover too. So we're going to come back in a minute for video number 2, just to show you it cycling on and off at about 20 or 22 F range.